Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on this logistic regression. You have seen the various machine learning algorithm. In this machine learning algorithm, in the first algorithm what we completed, that is the naive Bayes algorithm. This is the second one, we call it as the logistic regression. Even if the name is regression, but it is one classification algorithm. This logistic regression, it is a statistical method. I told you the different type of method. It is a statistical method that is used for building machine learning models where the dependent variable is purely binary. Remember that one. So the x-axis we are representing the independent variable, y-axis we are representing the dependent variable. And this logistic regression, it is used to describe data and the relationship between one dependent variable and one or more independent variables. Is it clear? That means the dependent variable in the y-axis is only one that we are going to predict, and the independent variable it will be at least one or more than one. It's clear? The independent variable can be nominal, ordinal, or can be of interval type. So we are having the various type of data here that I am giving a brief description, because without understanding those different type of data, so it will be meaningless to tell you what is the quantitative, what is qualitative, what is numerical, what is categorical. Now see, we have two types of data. So one is the categorical data, second one is the numerical data. Categorical data also we call it as the categorical, we also call it the qualitative data. The numerical data we call it as the quantitative data. Is it clear? So this qualitative or the categorical data, again it is divided into two. So one is the nominal data, second one is the ordinal data. Okay, left hand side we divided, that is the qualitative data, that is nominal data, and second one is the ordinal data. Fine. Similarly, the numerical data or the quantitative data, it is divided into discrete data as well as the continuous data. Fine. Now let us study one by one. We take various example. From this example we can understand. We are going for this first qualitative or categorical data. Say for example, I give an example, the birth date. How do you represent the birth date? Suppose my birth date is 3rd January 1960. Is it a number? Is it a number? No. It is never a number. So these are the categorical data. But I say 1, 2, 3, 5, 20, 80, 90. These are numbers. But 3rd January 1960, it is not a number. And this type of data, it is coming under this categorical data. So this qualitative data, I told you that we divide into two. One is the nominal, one is the ordinal data. The nominal data, say we are representing by some letters, some symbols, words, gender, occupation, etc. Say for example, I say male, female, this type of data. So this is coming under this nominal data. Okay. Similarly, ordinal data, this is the data that follow a natural order. For example, if I go for the socio-economical status, so socio-economic means is the income. So it can be low income, it can be middle income, it can be high income. Suppose I go for the educational level of data, it can be high school, it can be bachelor's degree, it can be master degree, it can be PhD. All the things are coming under this educational level. Similarly, coming to the income level, it can be less than 50k, 50,000, or between 50,000 to 100,000, like that. So these are the two category of data. It is coming under this qualitative data or the categorical data. Then coming to the quantitative or numerical data, we can say the example of some numerical data or digits. Say for example, the height, the length, the size, the weight. All the things are the quantitative or the numerical. Say height, somebody 6 feet, length is 180 centimeter, the size is something, then weight is 50 kg or some pound or some, like that also you can represent. Then coming to the discrete data, this quantitative data we have divided into two categories. One the discrete data, second one is the continuous data. Discrete data, say I am telling number of students in the class is 60. This is the discrete data. Continuous, so it is a range, say the temperature range from 20 to 24 degrees centigrade. This type of things it is coming under this continuous data, right? So these are the various type of data. We should have some clarity. Then we are going for this actual the logistic regression. The name logistic regression, it is derived from this concept of this logistic function. And this logistic regression uses that particular type of logistic function, right? The logistic function is also known as the sigmoid function, and this value of this logistic function lies between 0 and 1. So whatever the values of this logistic function, it lies between 0 and minimum is 0, maximum is equal to 1. And the logistic regression algorithm, let us take an example where we can understand. Suppose in an organization we want to determine the employee's salary or the salary of an employee. How to increase this salary based on his performance, or the salary of all the employees based on their performance. So for this what we do, we can use a linear regression algorithm. That means with the x-axis we represent what is his performance, in the y-axis we put what is the salary, right? So we try to fit to a line which is represented by this linear regression. So once we fit or once we train it, then for any experience we can predict what is the salary. So we plot a regression line by considering the employee's performance as the independent variable, it is in x-axis, and the salary increase in the dependent variable. So like this we can predict all the things. Is it clear? So these are the minimum things that somebody can understand about what are the things we are using for these things. Now let us see how do we represent this linear regression. Let us see how the linear regression is represented. So you see the employee's performance or rating is represented in the x-axis, I told you, and the salary hike is represented in the y-axis. Hike means it is the increment, it is not the actual salary. That means suppose somebody's performance is 1, say I am putting a grade of 1 to 5. If his performance is 1, the hike will be maximum 5,000. Say for example, if his performance in the 2, then his hike will be around 10,000. If it is performance 3, then it is tentatively it is coming around 12 to 15,000 rupees. If it is 4, so it is coming 15 above. So 5, it is coming around 20. Like that. In this what we did, see you can see against the independent variable, the employee's rating or performance, we are plotting all these values, scattered value. You can see all these data points. You can see all these data points here. Then what we do, we draw a line, what we call it the regression line. This line fits to the data. So exactly, because considering all these points, if you try to draw a line, it cannot be a line. But we compromise because some part is falling below this line, some part is above the lines. So this is the best fit line. So we call it as a regression line. So once we are able to go for the regression line, then whatever the rating here we put it there, suppose rating is 15 or 20, against we can find his salary will be 30,000 increment or 50,000 increment, like that it will be there. So this is the thing, we put it in our linear regression. But imagine that I want to give a promotion. I want to give a promotion to that particular employee. So can I give the promotion based on the same criteria? So there the answer will be no. Answer will be no. You see, you cannot get it. You see, somebody's performance is well. In the first year, can you give he is running the first year? Can you give a promotion? All automatically the remaining employees, they will leave, they won't stay. Somebody is already continuing here for 5 years or 8 years. He did not get a promotion. The people who joined 1 year back and he will get a promotion, there will be disturbances. So now we will take so many parameters and so many independent variables. Based on that, we can give you all the things. When we go for this type of things, it will be difficult to represent it by this linear regression. So for that, what we do, for this what we do this linear graph, above linear graph, it will be unable to explain all the things. So in that case, we try to use another thing, what we call it the logistic function or the logistic regression. this logistic regression, we clip the line at 0 and 1. So this will be there between 0 and 1. The minimum value is equal to 0 here and the maximum value is equal to 1, and it will be converted to a sigmoid curve, just like S shape. Can you see it here? Sigmoid curve. It will be just like a S-shaped curve. So using these things, I can better represent the logistic regression. Okay, and I can be able to predict what is the salary or whether that particular employee can get a promotion, right? So now let us go in details. From this we can understand the logistic regression. Now let us see, to understand this logistic regression, let us go over the odds of function, odds of success. Okay, we go for this odds of success. What we call it as the odds of success, right? What is this odds of success? Suppose odds of theta, that means the probability of an event happened by the probability of an event not happened. Okay, odds of theta. How do you calculate this odds of theta or the odds of success? The odds of success, the probability of an event happening divided by the probability of event has not happened. Suppose P is the probability happened, total is equal to 1. So not happened will be 1 minus P. You get it? No, it is because 0 to 1. It is represented 0 to 1. Okay, are you getting me? If the probability of happening it is P, the probability of not happening it will be 1 minus P. So P divided by 1 minus P, that is odds of theta. Okay, or we call it the odds of success. Now the value of this odd ranges from 0 to infinity. The value of these odds ranges from 0 to infinity, and the value of the probability lies between 0 and 1. The probability lies between 0 and 1, and the value of odds ranges from 0 to infinity. Now let us consider the equation of a straight line. Y is equal to beta 0 plus beta 1 x. Okay, what is beta 0? Beta 0? Beta 0 is the y intercept. You see, this line is intercepting the y axis. This is the y axis, this is the x axis at the point beta 0. That means at a height beta 0, it is intercepting the y axis. Then beta 1 is the slope of the line. It is the line, if you draw here, then dy by dx, it is the slope. Okay, this is the angle tan theta or tan, whatever angle you say it here. So this beta 1 we call it as, it is just like if you remember y is equal to mx plus c, the same thing we are trying to represent. Here m is equal to beta 1, c is equal to beta 0, and x is the value of the x coordinates and y is the value that we are going to predict. Okay, so x is represented here in this x axis and y that we are going to predict. You get it now? So this is the concept what we are using, the odds of success, which is represented by theta is equal to p is equal to theta is equal to p divided by 1 minus p, right? Now again we go for some mathematical calculations. Based on that we can understand this logistic regression properly. Now let us see, we are having we are going to predict the odds of success with the following formula. So what we do it, this say initially it was p divided by 1 minus p, p divided by these are things. Okay, then which was represented by beta 0 plus beta 1 x. What is that? E to the power beta 0. Are you getting me? So now if I go for the logarithm of that one, then logarithm of px divided by 1 minus px, which is equal to logarithm of these things, it becomes beta 0 plus beta 1 x. Okay, y is equal to like that we have given. Now if you go for the are you getting me? This is the logarithm functions, logarithm of px divided by 1 minus px, which is equal to beta 0 plus beta 1 x. Okay, because this function or this value what we have put it, p divided by 1 minus p, it is represented with the logarithm functions, logarithm of the p divided by 1 minus p. Now if you go for the exponentiating both the sides, then e to the power log, what will happen? Log and e will be cancelled automatically. That will be px divided by 1 minus px. Then right side it become e to the power beta 0 plus beta 1 x. Are you getting me? So e to the power beta 0 plus beta 1 x, which is equal to px divided by 1 minus px. Are you following me? So this is the simple mathematics we know. and we can using these things we can do all the things, right? Then I am going for our linear regression slide number 6, where we can understand the things in details. Now let us see. Now we have taken y, which is equal y is equal to mx plus c, y is equal to e to the power beta 0 plus beta 1 x, that I have already taken. Okay, are you getting me? So now that is the first one is the equation. Now I have taken px divided by 1 minus px, which is equal to y. Y is equal to e to the power something I have taken, no, that I have taken y. Okay, I am assuming y is equal to this one. Okay, e to the power beta 0, because how we got that one? Because logarithm of p divided by 1 minus p, which is equal to beta 0 plus beta 1 x. So we have go for the exponentiation of both the sides. So exponential of log is equal to 1, that you know. That means px divided by 1 minus px, it will be there, and the right hand side which is equal to y. Now simplifying all the things, then px, this denominator will be multiplied with y, that is equal to y into 1 minus px. Okay, then px, which is equal to y multiplied here expanding minus y into px, right? Then this px, this minus y px, it come to the left hand side, px plus y px, which is equal to y. Or if you take the px is outside, that 1 plus y, so px into 1 plus y, which is equal to y, or px is equal to y divided by 1 plus y. Got it now? So px is equal to y divided by 1 plus y. What is this y? Y I have taken e to the power beta 0 plus beta 1 x. So putting all this value, so y means e to the power beta 0 plus beta 1 x divided by 1 plus e to the power beta 0 plus beta 1 x. Okay, so dividing this e to the power beta 0 plus beta 1 by x and the numerator and denominator, so this become 1, so this become 1, this become e to the power minus beta 0 plus beta 1 x, the same thing. Now the probability function px, which is equal to 1, now this is the sigmoid function, not probably the sigmoid function. The sigmoid function, which is equal to 1 divided by 1 plus e to the power minus y, or 1 e to the power minus beta 0 plus beta 1 x. Okay, if the same function we want to plot, you will find a function like this. You will get a function like this. Can you see it here? Our function, it is represented the x axis when x is equal to 1, 2, 3, 4 like this, and finding the suitable value of beta 0 and beta 1, we can plot it and we can get the function, it is coming like this. Okay, so this was about all the things. Now let us see some of the applications where we will be using. For this thing, let us see where we can use this type of logistic regression. See, we have a number of applications for this logistic regression. The important applications are using logistic regression algorithm. Banks can predict whether a customer would default a loan or not, because all the people are interested to take loan. Most of the people are interested to loan, but how many people they repay the loan? So then how the bank will trust and give a loan? Because there will be different type of loan. There will be pressure from the government to give the agriculture loan. There will be from house loan. There will be from vehicle loan. So many people loans are there. But it is a bad habit. People, while they need a loan, they approach anybody like anything. But once they have taken the loan, it is they forget successfully and they hesitate to return in time. And sometimes they don't return also. So it becomes the responsibility of the manager. So he has to check by some means whether this person who is applying for a loan, he will be able to repay it or he will be a defaulter, like that. To predict the weather condition of a certain place, like it will be sunny day or windy day, why this is required? Suppose I am planning for a international cricket match tomorrow at some places like Hyderabad or some Baravati Stadium, Cuttack, or some stadium at Calcutta. Okay, then if I plan for a match, then I have to predict whether it will be a sunny day or a windy day or a rainy day, humid day. So suppose I plan a cricket match in a rainy day like this. So when it will be raining, how can I play cricket? It is not possible. Or it is a windy day, a lot of cyclone is there, a lot of wind is there. So it is not possible to play also. If it is, so like that. So I want to predict the weather. For that, this logistic regression is the most suitable. Similarly, e-commerce companies can identify buyers if they are likely to purchase a certain product. Suppose I am going to, because now Dasara Puja is coming, so the e-commerce people, they want to sell number of products, their product. Okay, so now they want to predict whether a particular customer or some customers, they are going to buy a particular item or product. Okay, so based on the predicts, they can increase some stock, they can decrease some stock, like that. Okay, the companies can predict whether they will gain or lose money in the next quarters. Say suppose the entire year, so we divide into 4 quarters. The first quarter it is a gain to me, but the second quarter will be gain to me or loss to me. The company can also predict year, or in a year also, or in a month also, we can also predict all things. And to classify objects based on their features and attributes, for that reason we use these logistic regressions. Now remember, whenever we come across this type of things, then logistic regression is more suitable for this, right? So there you can apply this type of things, right? Now we are going for the last slide here, where we will be covering what are the things we have to remember, or I can say what are the assumptions in a logistic regression, so we have to take it. See, the dependent variable must be binary. That's why we call it the binary logistic regression. The independent variable I am not bothered, it can be one variable, it can be more than one, x1, x2, x3, xn, up to xn you can take it. But the dependent variable which represent in the y-axis, it must be a binary. This is the assumption. For a binary regression, the factor label one of the dependent variables should represent the desired outcome. Okay, the dependent variable should represent the desired outcome. Here only meaningful variables should be included. There are so many variables, no need to include all. What are the meaningful things, only that is to be included. The independent variable should be independent of it, that there should not be that much of correlations with them. They must be independent of each other. And this means that models should have little or no multi-collinearity. The last point is that the independent variables are linearly related to the log odds. So these are the assumptions, and based on these assumptions we can go for this logistic regression. I have already discussed the area of applications, and we will be discussing about the implementation part using the Python. So I hope if you understand this concept, so please do share with your friends, and also don't forget to subscribe also. And the next part, once we complete all these 7 number of this type of our supervised learning based things, machine learning based classifiers, and another 3 based also on supervised, then we will be going for this implementation in the Python. Okay, thank you for watching this video. Okay, so please take care of health and have a good day.